Section 6.4 is on exponential growth and exponential decay. So for your learning targets, you'll be able to identify exponential growth and decay functions, and you will be able to interpret and rewrite exponential growth and decay functions. So for your core concepts, we have one for exponential growth and one for exponential decay, and they're pretty much the same thing. The only difference is this addition sign in here and the subtraction sign in here. So in both equations, A is the initial amount, R is your rate of growth or your rate of decay, and that's usually a percent written as a decimal. And then T is going to be time. So we're jumping to example 2, which is identifying exponential growth and decay. So when we're looking at our tables, we always want to determine what we're multiplying by. So when I look here, if I look at how I get from 24 to 12, then 12 to 6, and then 6 to 3, you could say that you're dividing by 2. But when we work with exponential functions, we always want it in terms of what we're multiplying by. So dividing by 2 is the same as multiplying by 1/2. Okay, so the same thing for dividing by 3. If I was dividing by 3, that's like multiplying by 1/3. If I'm dividing by 4, that's the same as multiplying by 1/5. If you see that your numbers are decreasing, they're going down, and you're not sure what you're multiplying by, do the second term divided by the first term. So 12 divided by 24 gives you 1/2 or 0.5. So since I am multiplying by 1/2 or 0.5, these numbers are going down. The answer here is exponential decay. So now for our next one, we want to look at how we're getting from 4 to 40, 40 to 400, 400 to 4,000. And again, here we're multiplying by 10. These numbers are going up, and so our answer here is going to be exponential growth. So for example 3, you're determining whether each function represents growth or decay again, and you're identifying the percent rate of change. So we're looking at this number inside the parentheses. So I have 1.09. Whenever you start with 1 point, whatever that number is after it, this is going to be your percent rate of change as a decimal. So I have on this part, after the 0.09, so this is going to be 9% as my rate of change. And when you have 1 point something, again, that's going to be exponential growth. So we have 2 answers for this problem. Over here, again, we're still looking at what's inside the parentheses. We have 0.93. This time, this 0.93, you're going to subtract that from 100. You always are going to subtract from 100. 100 minus 93 is 7. So our percent rate of change here is 7. And because we're leading with a 0 here, this is going to be decay. Example 4 is rewriting exponential functions, and then this is going to help us determine if it's growth or decay. So if you look at our first equation, it's not written in like that standard form where just our exponent here is t. So that's where we're going to have to do some rewriting. So we're going to use some of our properties of exponents. So I'm going to start by rewriting this one. So we have y equals 20 times 0.81, and I'm going to bring this 1/2 power on the inside of my parenthesis to the t power. So if you remember, the power to a power property means you multiply these exponents. So 1/2 times t would be t over 2. So now we need to simplify this 0.81 to the 1/2 power, or doing the square root of 0.81. So if you recognize 0.81, that's a perfect square. 81 square, or the square root of 81 is 9. So the square root of 0.81 is going to be 0.9, and then this is to the t power. So this is our equation rewritten. And then if we look at our number inside the parentheses here, we have 0.9. So this is going to be decay. Again, if you have 0 it's decay. So now for our second one, we have f of t equals 2.5 to the t minus 2 power. So I'm going to go ahead and start rewriting this one. And this one can be rewritten as 2.5 to the t power over 2.5 squared. So if you think back to your properties, when you are dividing like bases, you can subtract the exponents. So this can be rewritten in this as this using the properties of exponents. So now for us to continue to simplify this, I'm going to pull this 2.5 squared out in front. So I'm going to write it as 1 over 2.5 squared times 2.5 to the t power. And then if we were to simplify 1 over 2.5 squared, we would get f of t equals 0.16 times 2.5 to the t power. So now again, we're looking at what's inside the parentheses. We have 2.5. So as long as it's 1 or more before the decimal, it's going to be growth. So this is an exponential growth function.